Okay, in this Algebra 2 lesson, we're going to be looking at the focus of a parabola. During this lesson, we're going to explore the focus and the directrix of a parabola. We're going to write equations of parabolas and solve real-life problems. A parabola can be defined as a set of all points in a plane that are equidistant from a fixed point, which is called a focus. In our diagram, the focus is this point. It's also equidistant from the fixed line called the directrix, and this line is our directrix. The distance between the focus and a point on the parabola is equal to the distance between the directrix and the point on the parabola. So from the focus to a point on the parabola, this distance is equal to the distance from the line that's the directrix to the point on the parabola. Further up the parabola, this distance is the same as that distance. Notice, by the way, that the focus is on our line of symmetry, and the vertex is halfway between the focus and the directrix. Here's the directrix, there's the vertex and the focus. We can use the distance formula to write an equation for a parabola. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's use the distance formula to write an equation of the parabola with focus at 0, 2 and the directrix at y equals -2. So the first distance that I'm going to look at is the distance between the focus and the point on the parabola. Using our distance formula to write this distance, we'll call that distance 1. Is the square root of the x-coordinates, the difference in the x-coordinates, so x minus 0 squared, plus the distance between, or the difference between the y-coordinates, so we have y minus 2 quantity squared. That's our first distance, our distance between our focus and our parabola. Now the distance between the parabola and the directrix, again using our distance formula, we'll call that d2. So the square root of our x-coordinate subtracted. So we're going to have x minus x, quantity squared, and then our y-coordinates, y minus -2 squared, or y plus 2 quantity squared. These two distances have to be equal, so let's set them equal to each other. Simplifying as we go, x minus 0 is just x, so we have x squared plus the quantity of y minus 2 squared under the square root equal to, on the other side, simplifying as we go, x minus x is 0, so this term drops out, leaving us with just the quantity y plus 2 squared under the root. To solve this equation, we're going to square both sides to get rid of the root. So we have x squared plus the quantity y minus 2 squared equals the quantity y plus 2 squared. To solve this equation, we're going to expand the two binomials, multiplying those out. I'm going to write that out to remind you how that works. Y minus 2 squared is y minus 2 times y minus 2, and y plus 2 squared is y plus 2 times y plus 2. Now foiling, first outer inner last, we have x squared plus y squared for our outer. Inner and outer are going to be -2y and another -2y for -4y. And last, -2 times -2 is 4. Doing the same on the other side gives us y squared plus 4y plus 4. Now let's do some simplifying. Notice on each side we have a y squared, so subtracting y squared from each side makes those two 0. And the same thing with 4, subtracting 4 from both sides, and the 4's drop out. So that leaves us with x squared minus 4y equals 4y. Solving for y by adding 4y to both sides gives us x squared equals 8y. And then solving for y is equal to 1/8 x squared. Notice that our vertex is at 0, 0. It opens up. It's a vertical shrink because we have 1/8. That means our opening for our parabola is very wide. Okay, in our next example, we want to generalize those results so we don't have to go through the distance formula all the time. If we can come up with a formula or a rule that happens every time, then we won't have to use the distance formula. So we're going to look at a parabola with a focus at 0p and our vertex at the origin. So this is going to be the point 0, 0. And we're going to use our distance equations to come up with our equation for our parabola. So a point on our parabola, we can call it this one, is xy. Directly below it, as we go to this point right here, our x is the same x coordinate. And as we look at it, notice, by the way, our distances here. If this is 0p and our origin is 0, 0, this distance between the vertex and the focus is p. Since it's an equal distance to the directrix, this distance down here is also p. So our coordinates of this point, if we come out here on the x-axis, has to be down at negative p. Okay, so let's use our distance formula again. Our first distance is the distance between the focus and the point on the parabola. So that distance is the square root of our x-coordinate subtracted, x minus 0 squared, or x squared, plus y minus p, quantity squared. And that's equal to our distance between our parabola and our directrix. So we've got the square root of our x-coordinate subtracted. X minus x is just 0, so that drops out. And our y-coordinates, y minus negative p, or y plus p, quantity squared. Those two distances are equal. Now let's square both sides to get rid of the root. So we have x squared plus y minus p, quantity squared, equals y plus p, quantity squared. Again, we're going to expand these binomials by multiplying them out. So we have x squared plus y minus p times y minus p equals a quantity y plus p times y plus p. Multiplying that out gives us x squared plus y squared minus 2p times y. Our outer term is negative 1 yp. Our inner term is negative 1 times yp. So there's two of those multiplied together. And our last term, negative p times negative p, is positive p squared. Same thing on the other side, except instead of a minus, we have a plus. So we have y squared plus 2py plus p squared. Okay, so simplifying, as we subtract y squared from both sides, our y squareds go. And subtracting p squared from both sides, our p squareds go. Leaving us with x squared minus 2py equals 2py. Adding 2py to both sides of our equation gives us x squared equals 4py. Dividing both sides by 4p gives us y is equal to x squared over 4p, or times 1 over 4p. That then is a rule for finding our equation of our parabola, and the only thing we need to know is the value of p, which is our distance between our vertex and our focus. So it's an equation, vertex at the origin, focus at 0p, and we have this equation. Now, one of the neat things about a parabola is we're actually going to be looking at parabolas not only opening up or down, but we can be looking at parabolas opening to the right or to the left. In our first one, our equation is our typical equation like we have here, y equals 1 over 4p times x squared. If p is positive, the parabola is going to be opening up. If p is negative, it's going to be opening down. Our vertex is at the origin, our focus is at 0p, and our directrix is at the point y equals negative p. P and negative p. Okay. Sideways, the equation looks almost the same, except it's x equals 1 over 4p times y squared. And our focus then is at p0, it's on the x-axis, and our directrix is a vertical line, x equals negative p. Again, positive p, it opens to the right. Negative value for p opens to the left. So let's do an example with that. In this example, we want to identify the focus, the directrix, and the axis of symmetry of the equation for the parabola negative 4x equals y squared, and then we want to have our graph. The first thing that we want to do is we want to get it in standard form. So standard form in this case is solving the equation for x. So taking the equation, dividing by negative 4, we get y equals x equals negative 1/4 y squared. This is going to be an x equals y squared. This is going to open horizontally. And since the p is negative, this is going to open to the left. We can write that as x equals 1 over negative 4 y squared. Compare it to our standard form of x equals 1 over 4p y squared. We can see that 4p equals negative 4. So p has to equal negative 1. So let's see what we can do with p equal to negative 1. We know what our vertex is. It says our vertex is going to be at the origin when it's in this form. Okay, so here's our vertex. We know that our focus is negative 1 unit away from the vertex. So our focus is going to be moving to the left 1 unit. So our focus is going to be at P0, which is negative 1, 0. Okay. Our directrix is going to be a vertical line. It's going to be x equals the opposite of p. So in this case, x is going to equal positive 1. Again, from our vertex, our distance is p, so we're going 1 unit to the right to get to our directrix. Now, in order to get the rest of the parabola, we're going to have to plot a couple of points. So let's do that. In this case, since it's x equals y squared, it's easier to substitute something in for y. So let's take a look at our equation. If we put a number in for y, we get our value. We could put 1 in for y. If we substitute 1 in for y, we're going to have negative 1/4 times 1 squared, or negative 1/4. If we put 2 in for y, we're going to have 2 squared, which is 4, times negative 1/4 is going to give us negative 1. So let's graph those points. We have x is negative 1/4 and y is 1. We have x is negative 1 and y is 2. Our axis of symmetry, which we haven't mentioned yet, remember our axis of symmetry goes right through the focus and the vertex. So our axis of symmetry is right here. So our axis of symmetry is y equal to 0. Okay, and so I can reflect these points over our axis of symmetry. So at negative 1/4, we have negative 1, and at negative 1, we have 2 and negative 2. So here's our graph of our parabola opening to the left. Let's take a look at another example. In this case, we have a parabola and we want to come up with the equation. This is a parabola that's opening in the vertical direction. It's opening down. Since it's in the vertical direction, it's in the form y equals 1 over 4p x squared. So in order to get the equation, all we need to do is find what p is. Remember, p is our distance between our focus and our vertex, but also p is the distance between the vertex and the directrix. So here's our vertex at 0, 0. Straight up, we see our directrix goes by a scale here of 1, so 1, 2, 3. Our directrix is the line y equals 3, so our distance from our focus to our directrix P is 3 steps. So our equation is y equals 1 over 4 times 3 x squared, or 1/12 x squared. Okay, now the vertex can be translated horizontally or vertically, moving like we did with transformations or translations. Remember, we had H's and K's. So when the vertex is translated horizontally or vertically, we apply the translation to the standard equation. Remember, a translation of H moves a graph left or right, and a translation of K moves our graph up or down. So let's see how that changes our equation. If we take a parabola, which has a vertical axis of symmetry, so that's our usual y equals x squared, or y equals 1 over 4p x squared, we can move it to the left or the right. So y equals 1 over 4p x minus h squared plus k. Our new focus is going to be moved from k up by p, and our new directrix is going to move down from our negative p. It's going to go k minus p. If we have a horizontal, looks the same idea, but this time our h and k, since our parabola, our vertex is moving left and right here, or up and down. Remember, our h is our horizontal, our k is our vertical. So when we do that, when we have y squared, to translate in the y direction, we have y minus k quantity squared, and then plus h. Let's see how that works visually. Here's a parabola. We want to identify the axis of symmetry, the vertex, the focus, and then find the equation. Notice our parabola opens sideways, so it's going to be an x equals 1 over 4p, and we're going to have y minus k squared plus h. The k is going to change the y, the h is going to change the x. So let's see what we have. The first thing I need to know is find out what p is. Remember, p is our distance from our vertex to our focus. So here's our vertex, there's our focus, our scale is going by 2's, so our distance is 2, 4. So p is 4. The next thing I need to find is the vertex, which is going to give us our h and our k. So our vertex is at the point 2, 4, 6, 2. That means h is 6 and k is 2. Since it's an x equals, we have the y minus k. The term that is translated up is our k, which is 2. So let's plug in some numbers. We have x equals 1 over 4p, so 1 over 4 times 4. Y minus k, our k is 2, quantity squared, plus our value for h of 6. So we get x equals 1/16 y minus 2 squared plus 6. Vertex 6, 2. and it opens wide, 1/16, and it's opening to the right. Okay, let's take a look at another example. In real life, parabolic dishes, parabolas, are used in 3 dimensions to make reflectors, satellite dishes, mirrors, telescope, lenses. All of those use different conic shapes, one of which is a parabolic shape. So let's see a real-world example here. We have an electricity generating dish uses a parabolic reflector to concentrate sunlight onto a high-frequency engine located at the focus of the reflector. The sunlight heats helium to 650 degrees centigrade to power the engine. So what happens is that the sunlight comes and it strikes the edge of the parabolic dish, and it will reflect back up to the focus. So no matter where the sunlight strikes the dish, it will reflect that sunlight to the focus, so it concentrates that sunlight at one point, collecting that heat. Okay? So the sunlight heats the helium to 650 degrees Celsius to power the engine. That's really good temperature there. We want to write an equation that represents the cross-section of the dish shown with its vertex at 0, 0. Since the vertex is at 0, 0 and our dish opens vertically, our equation is of the type y equals 1 over 4p x squared. All I need to find is p. Remember, p is our distance between our vertex and our focus. So from our diagram, we see that this distance is 4.5 meters. So p is equal to 4.5 meters. So our equation is y equals 1 over 4 times 4.5 x squared, or y equals 1 over 18 x squared. So that's part 1. Part 2, we want to know what the depth of the dish is. So as I'm looking at this point right here, I want to know how tall that is. So I need to find a value for x to find out what y is. Notice that we're 8.5 meters all the way across here. So halfway across is going to be 4.25. So I'm going to put 4.25 in for x in my equation. So y equals 1 over 18 times 4.25 quantity squared. And I haven't calculated that yet, so let's do that very quickly on our calculator. We can do that. 1 divided by 18 times 4.25 squared. And we get 1.00. So our depth is going to be 1 meter deep. And that's finding focus and directrix of parabolas.